Hi everyone, I'm Rachael Sinclair and this presentation is a summary of the Prepared Report 007, Challenges and Solutions for Offshore Wind Farm Cumulative Effects Assessments for Marine Mammals. I'm a principal scientist at SMRU Consulting, which is a marine mammal consultancy based at the University of St Andrews. I've worked here for nearly 12 years now, and my work focuses primarily on assessing the potential impacts of offshore wind farms on marine mammals. I've worked on over 20 offshore wind farm environmental impact assessments around the UK. And what I find interesting is that the advice and the guidance varies between regulators. And so our assessments differ depending on what country we're in, whether it's Scotland, England, Wales, or Ireland. But all of them require a cumulative effects assessment. Now, I'll clarify here what I mean by a cumulative effect assessment. For offshore wind farm projects in the UK, we quantitatively assess the potential for behavioural disturbance from pile driving at multiple offshore wind farms. That's the focus of the assessments. For other impact pathways, we tend to do a more qualitative assessment, not at the stage of stresses yet. Before I go any further with my talk, I'd like to clarify something. Please do not misunderstand me during this presentation. I think cumulative assessment is essential. Of course, we need to understand the impact not only from a specific offshore wind farm development, but also the potential impacts from multiple offshore wind farms, especially given how many are planned to be constructed in the UK over the next 10 years or so. The point of this presentation is to outline why I think the current system used in the UK for offshore wind farm cumulative effects assessments doesn't work. Because of various issues with the current methods, I often feel like we have little confidence in our assessment results. Now, there is guidance available for nationally significant infrastructure projects, and this includes offshore wind farms, on how to do a cumulative effects assessment. And this breaks the assessment into 4 stages. Stage 1 is establishing the long list. Here we identify the zone of influence, which is essentially the area that we will include in the cumulative assessment. Stage 2 is to establish the short list. Here we identify which projects should be screened into our cumulative assessment. Stage 3 is information gathering, where we collate information for each of the offshore wind farms that are screened into the assessment. And then stage 4 is the actual assessment itself, where we do an assessment of whether or not there is likely to be a cumulative effect on the population. Now, this sounds simple, but I assure you it's not. So what we're going to do is go through each of these steps and highlight some of the key issues that we're currently experiencing in the process. So let's look at stage 1, the zone of influence. The NCEP guidance says we need to define our zone of influence in which the cumulative effects might occur. So let's imagine a hypothetical offshore wind farm in the Irish Sea. What can I say is my zone of influence for behavioural disturbance from pile driving activities? Well, different regulators advise different zones of influence, and different consultants use different zones of influence. I could say in this scenario that my zone of influence is the Irish Sea. Or I could say that the Celtic and Irish Sea Management Unit is my zone of influence. Or I could use a distance-based zone, for example, a 500-kilometre ADR. Or I could use the OSPAR Region 2 Assessment Unit. Or I could take it one step further and use the entire Celtic and Greater North Sea Management Unit. You can clearly see that this step makes a massive difference to the assessment. So our key issue here is that regulator guidance differs on what the zone of influence should be. So there's no consistency in the zone of influence that is applied across assessments, and that means there's no comparability across projects. For example, an offshore wind farm could screen in less than 10 offshore wind farms into its cumulative effects assessment, or it could screen in over 100. Stage 2 is creating the short list of projects that we actually want to include in the assessment. Here we screen in projects where there is the potential for a cumulative effect. We typically screen out projects because there is no temporal overlap or because there's low data confidence. But what is low data confidence? Does that mean I should screen out all offshore wind farm projects that don't have consent yet? Or should I screen out projects with no environmental impact assessment yet? Or screen out projects that have no scoping report yet? Well, that's not a very precautionary approach. Secondly, what is temporal overlap? Here, let's imagine I'm working on an assessment for an offshore wind farm that is constructing in 2027. What other projects do I include in my cumulative assessment? I could include all projects that are also constructing in 2027. Or I could include all projects constructing between now in 2025 and 2027. Or I can include all projects constructing between my baseline data collection in 2021 and the end of my construction period. Or I could assess the whole time period covering all construction for all offshore wind farms in my zone of influence. Our decisions here mean that the number of years included in the cumulative assessment can vary between just a couple of years and over 10 years. Step 3 is the data gathering stage. We have identified our zone of influence, we have screened in projects within that we want to include in our cumulative assessment, and now we want to collect data on each of the offshore wind farms that we're screened in. But where do we get this data from? There are numerous data sources that are typically used. That includes the Crown Estate Open Data Portal, the EMODnet Data Portal, the 4C Offshore Database, for example. We could go to project-specific websites or use the latest application submissions, for example, scoping reports, PIR, EIAR, for example. Then how do we get the number of animals impacted per piling day at each project? Well, that's difficult because we have different density estimates, different disturbance thresholds that are used across different assessments. What about projects with no environmental impact assessment available? Then we need to get piling information for each of the projects. This involves the number of piling days per year and the number of years in which piling will occur. Unfortunately, different data sources tend to be updated at different times and therefore give us different information. What's in a scoping report or an EIA might not match what's on a public database or what's on a project-specific website. Then different EIAs use different methods to assess disturbance, as well as using different underlying density surfaces to estimate the number of animals that are impacted. This means that they aren't comparable. Then what do we do about an offshore wind farm where no EIA is available? Do we screen them out? Or should we be precautionary and make some form of assessment for them? Finally, piling information is lacking in many EIAs and for projects that are definitely in the pre-EIA stage. So there is extremely little certainty as to what year piling will occur in, let alone the number of piling days over a year. Finally, we get to stage 4, the assessment. Having collated all the information on the different offshore wind farms, we now make an assessment as to whether or not there's going to be a cumulative effect. Couple of key issues here. If we take values from EIAs to use in the cumulative effects assessment, then we're using worst case scenario values. If we combine the worst case number of turbines with the worst case number of piling days, the worst case number of animals disturbed, it all adds up to an assessment that is overly conservative and unrealistic, bearing little resemblance to what's likely to occur in reality. For example, assumptions about the number of projects constructing at the same time can lead to unrealistic assessments. I've seen cumulative effects assessments that have assumed over 30 offshore wind farms might be piling in UK waters at the same time. That's pretty much impossible. I don't think there are enough piling vessels in Europe or even potentially the world to do this. Here are a couple of examples for projects in Scottish waters that show the difference between what is assessed in an EIA and what is actually built. For example, at the Moray East project, the real number of days on which impact piling occurred was only 18% of what was assessed in the EIA. And that's because for this project, they installed significantly fewer turbines than the EIA assessed. At Seagreen, the real number of days on which impact piling occurred was only 3% of what was assessed in the EIA. And that's because for this project, they installed the turbines using suction buckets, and it was actually only the offshore platforms that were pile driven. And then we go to an extreme example where the LNG project, no piles were installed with impact piling. It was all done using drilling. So here we can see that there's no resemblance between the EIA and what's actually built. Now, finally, at the end of all of this, we assign a magnitude score. We combine it with a sensitivity score and we get our significance of effect. But how do we assign a magnitude score? Is it based on the total number of animals disturbed, the proportion of the population impacted, or whether or not there's predicted to be a population level decline from IPCOM modelling, for example? There's no consistent guidance or standardization for magnitude scores when evaluating the level of impact for a given pathway. Different projects apply different magnitude definitions, which can deviate to the extent that exactly the same result might be classified as a high or a low magnitude score, depending on your definition. And it's concerning that something so fundamental as the definition of magnitude can vary so much, making it essentially impossible to compare conclusions across impact assessments. All in all, I hope I've highlighted to you why I get frustrated with cumulative effects assessments and why I think the current system that we're using in the UK isn't working given the lack of guidance or standardisation in methods. But it's not all doom and gloom. I do have some suggestions for the way forwards. There are a couple of options that we could consider here. Option 1 is to move away from every offshore wind farm doing their own cumulative effects assessment and instead do a strategic level assessment. Now, I love the Dutch approach where the regulator conducts a cumulative effects assessment that they call a KEC, which is a framework for assessing ecological and cumulative effects. Option 2. If we're going to continue making each offshore wind farm do their own cumulative effects assessment, then we need to standardize the process. We need to standardize the zone of influence used for each species. We need to standardize the time frame assessed. We need to align on the information sources that we get data from. We need to decide on how to include projects without an EIA. We need to standardize our definitions for magnitude, and we need to set realistic limits on things like the number of piling days or the number of projects that are piling within a year. And in order to do this, we need a workshop and guidance from regulators and the SNCBs as soon as possible to make this process better. That's the end of my summary. Thank you very much for listening. Having done this for 12 years now, I really do hope that we can come up with a better way going forwards. This report is available on the OEC Prepared website. And if you are interested in knowing more, there are 2 follow-up case studies on the way. One is going to be showing an example of a cumulative assessment done with and without projects that don't have an EIA. And a second case study providing more information on the difference between what is assessed in an EIA worst case scenario and what is actually built. Thank you very much for your time.